Suppose we choose a simple random sample of 6 pregnant women. X bar is going to be the mean pregnancy length of this sample. What is the mean sampling distribution? Blah, blah, blah. So we know, in our case here, that the mean of our sample is going to be equal to the mean of our population, which is, was it 266?
Yeah.
266, since the population was approximately normal. The sample will be approximately normal as well. Okay, and the next one says compute the standard deviation of our sampling distribution. So we know that the standard deviation of our sampling distribution, whoopsie, that's ridiculous, sorry. Will be equal to, was it 16?
Yeah.
16 divided by the square root of our sample size, which was 6. Because they told us it was 6 back up here. And if somebody could calculate that. Thank you, 6.53 days. And then we're supposed to check to see if this is okay. The 10% rule. So first of all, the 10% rule says that our population, the way I talk about it, has to be greater than or equal to 10 times our sample size. So when we interpret this,
Pregnant women.
yeah.
More than 6.
The population of pregnant women is greater than 60 women. So I think we're fine. Find the probability that the mean pregnancy exceeds 270. So this is the same as kind of the problem before. We are going to find the probability that any given pregnancy is more than 270. So we're going to find a z-score for this thing. So for our z-score, we take 270 minus 266 divided by our standard deviation of 6.53. And I get somewhere around 0.61? 6026? 6126. So then as I calculate this, what we're talking about is the probability that our z-score is going to be, our z-score is going to be more than 0.6126, which is equal to normal CDF 0.6126, 99, which is equal to 0.27. 0.27, whatever, 0.1 is fine. So roughly a 27% chance that that'll occur.
It's humongous.
No crowds are going.
He's doing the force and process.
I was trying to, but they weren't letting. The ceiling was like 8 feet tall. The ceiling was 8 feet tall. There's no way. Okay, maybe 10 feet. I've been touching the ceiling.
I didn't read ever like pegged 3 times and still obtained information.
Okay, so we want to find the probability that the total number of texts is going to be more than 1,000 for a simple random sample of 50 high school students. That's our plan, or our state, sorry. And then In the next step, when we plan, the thing that's kind of interesting is for 1,000 texts and 50 students, this means the probability that the average number of texts per student is greater than 20. Or in other words, we're looking for the probability that the average number of texts is greater than 20. When you read these paragraphs, they always try to leave you clues. So in this paragraph, the clue that I had to do something like the 20, back up at the top here, they said that there was a mean of 15 per student, and that's why I wanted to find the average number of texts per student. Don't forget that they also give you a standard deviation of 35, but more importantly, it's right skewed. Is that going to matter for us? Why not? Because the sample is bigger than 50, or is 50, excuse me. So it's bigger than 30, so we don't have to worry about that. So I need to know, first of all, that when I look for this information, that the sample, since it's large enough now, I know that the mean of my sample is going to be, did they say 15, right? 15, and the standard deviation of my sample is going to be, the standard deviation which they gave me was 35 divided by the square root of my sample size 50, which my sources say 495, 4.95. Okay, so when I do this, that's what's going on. Then in my doing of this, as usual, we need to find a z-score. So our z-score is going to be equal to the score that we have, which was 20, minus the mean that they gave us, which was 15, divided by our standard deviation of 4.95, which gives me a z-score of 1.01.
Yep.
So then my probability, thank you, my probability is that the z-score is going to be bigger than 1.01, which we calculate to be 0.1562, which means that our conclusion is that there's a 15.62% chance that a random sample of 50 high school students will send in 1,000 texts per day. No. Sorry, I wrote down 1,000 students. And I meant 50. Will send in 1,000 texts per day.